So, usually when you sit down and read through these massive enterprise software updates or release notes, it feels a bit like, well, like buying a really advanced calculator.
Yeah, that's a good way to put it.
Right. Like you can see all the new buttons, it can process all this complex math, but at the end of the day, it's completely static.
It just sits there.
Exactly. It just sits on your desk waiting for you to punch in the exact right formula.
Which is, that's the traditional model of software infrastructure, right? You configure a tool, you set the parameters, and it executes precisely what you dictated.
Nothing happens without you.
Right. Nothing happens until a human initiates the action.
But looking at the sources we have for today's deep dive, and we're looking at a lot here, that dynamic is fundamentally changing.
Oh, totally.
It feels less like upgrading a calculator and more like hiring a highly autonomous executive assistant.
Yeah, one that doesn't just wait around for instructions.
Right. One that anticipates them, rearranges your files, maybe starts drafting emails before you even ask. And so our mission today for you, the listener, is to extract the most critical, actionable insights from Andrew Kagan's latest weekly newsletter.
And it's a massive scope this week.
It really is. We are looking at 8 distinct focus areas today. We've got Azure, Microsoft 365, Power Platform and Dynamics, DevOps and SRE, data analytics and AI, security, learning, and then just broader industry trends.
Which on the surface, that sounds like a totally disparate table of contents, just a random assortment of tech news.
Right, just a laundry list.
Exactly. But if you look at the underlying mechanics connecting all these updates, a really cohesive narrative emerges.
That is exactly what struck me. This isn't just a list of random software patches. This is the story of agentic AI waking up across the entire tech stack.
Waking up is the right phrase for it, yeah.
Right. And we are going to track this evolution today, from the foundational engines being built to the infrastructure, all the way to the honestly terrifying new security required to keep it from going off the rails.
And before we look at the tools you use every day, we really need to understand that fundamental shift. We are moving away from simple chatbots to actual agents.
So, okay, let's unpack this, because the newsletter breaks down the 5 key concepts behind agentic AI, and there is a statistic here that is just staggering.
The failure rate.
Yes. Roughly 88% of AI pilots fail to reach production today.
Which is just a massive failure rate for a technology that, everyone claims is changing the world right now.
88%. And according to the source material, it's not because the AI models aren't smart enough.
No, it's because enterprise teams lack the foundational engineering concepts to support them.
Right. And the first concept that really jumps out is tool use. Because an AI model by itself is, it's basically just a brain in a jar.
That just generates text.
Right. It generates text. But if it actually wants to do something like query a database or send a Slack message, it needs a bridge to the outside world.
And historically, building that bridge was an absolute nightmare for developers. You had to write these custom hard-coded API integrations for every single tool.
Oh, I can't even imagine the maintenance on that.
It was incredibly brittle. You had to maintain the connection, handle the formatting, update the code every single time the target software changed.
Which is where the Model Context Protocol comes in, right? MCP.
MCP is completely changing the paradigm. It's an open standard. So instead of writing a custom integration, an AI model can simply ask any MCP compliant server, hey, what tools do you have available?
Okay, wow.
And the server responds with a standardized list of capabilities, and the model can just call them dynamically.
So if you want your agent to talk to GitHub, there is an MCP server that just translates the agent's intent into the exact actions GitHub understands. But I got to push back on this a bit based on the text, because the newsletter treats MCP like this magic bullet. But standardizing that communication requires the AI to send extra context back and forth just to figure out what tools are available, right?
Right, the discovery phase.
Yeah, and doesn't that add massive token overhead?
Yeah.
If I'm building a high-throughput enterprise pipeline running like millions of database queries a minute, that token overhead is going to hurt performance and cost a fortune.
Sure.
Wouldn't I just hard-code a direct API call and skip the MCP middleman?
Well, you're right. If we're only optimizing for raw speed in a vacuum, a direct hard-coded API might be faster. But in an enterprise environment, raw speed is rarely your only priority.
Fair point.
You're dealing with strict data boundaries, multi-tenant architectures, and really complex authentication flows. MCP isn't just translating a request, it's handling the standardization of things like OAuth.
Okay, let's define OAuth for the listener really quickly, because it's everywhere, but people might not know the term.
Sure. So OAuth is basically the authentication handshake. It's the protocol that lets you grant a third-party app access to your data without giving them your actual password.
Like when you click login with Google on a random website.
Exactly. So when you have an AI agent jumping between, say, a financial database and an HR platform, handling those authentication handshakes securely is critical.
Right. You don't want it messing that up.
No, because if it does, your AI might accidentally leak payroll data into a public marketing Slack channel.
Oh, yikes. Yeah, that would be bad.
Very bad. So MCP standardizes that secure handoff. The token overhead you mentioned, that is just the price you pay for standardized security and scale.
Okay, that makes the trade-off a lot more logical.
Mm.
But even if the agent can use tools securely, it still needs the second major concept from the newsletter, which is memory and context engineering.
Yes, crucial.
And this brings up, honestly, my absolute favorite analogy for understanding large language models. An LLM without a memory layer is basically just a genius goldfish with a massive vocabulary.
Oh, a genius goldfish. I love that.
Right. Like, it can write a perfect Shakespearean sonnet about an Excel spreadsheet, but 5 minutes later, it has absolutely no idea who you are, what project you're working on, or what you were just discussing.
Which is exactly why memory architecture has become its own dedicated engineering discipline now.
Because we can't just stuff the entire conversation history into the model's prompt anymore.
No, you can't. That is way too expensive, and it actually causes the AI to lose track of details if the prompt gets too long. So context engineering involves using vector databases.
A vector database doesn't just search for exact keywords. Right?
No, it searches for the meaning behind the words.
Okay.
It translates data into numbers based on semantic similarity. So when you ask an agent about, Q3 revenue challenges, the system extracts only the most relevant facts from past conversations, tags them by user and session, and injects just that specific context into the prompt.
And Azure is really stepping up to provide this infrastructure, aren't they?
Massively. Azure Cosmos DB is now powering native agent memory for the Microsoft Agent Framework. It gives agents the ability to natively retain context across multiple sessions. And that memory retention, like you said with the goldfish, that is the actual bottleneck to building a reliable assistant.
Not just the raw parameter size of the model.
Exactly. It's about memory.
And the sheer compute power required to manage these agentic workloads is just mind-bending. The newsletter notes that AT&T and Microsoft are scaling trillion token workloads.
Trillion with a T, yeah.
Using Microsoft Foundry and AMD GPUs.
Yeah.
But at the same time, Microsoft launched new in-house models that cut costs by up to 89% compared to traditional OpenAI models.
And we also saw them introduce GPT Transcribe and GPT Live Transcribe in Foundry, which is huge for processing audio data at scale.
So they're scaling up and getting cheaper at the same time.
Yeah, we are really seeing a maturation in the market. The goal is no longer just building the most massive, expensive, generalized model.
Right.
It's about building efficient, purpose-built engines that can execute these memory-heavy workflows cost-effectively.
So we have the engine, we have the memory, the tool use, the compute. Now, how does this actually show up in the wild? In the enterprise spaces where you, the listener, actually spend your workday.
Right, in Microsoft 365 and the Power Platform.
Exactly.
Yeah.
Because think about your daily routine. Think about how many times you have dug through, 5 different corporate portals just to find an updated travel expense policy or some random onboarding document.
Oh, it's the worst.
Microsoft took aim at this exact friction internally. They built a massive Microsoft 365 Copilot connector to ingest their own internal company documentation.
And the scale of this internal deployment is just a masterclass in enterprise AI. They ingested 1 million documents.
1 million documents.
Yeah, and they're serving over 100,000 monthly users with it.
But the truly wild part is that this single connector spawned over 300 custom Copilot studio agents.
Right.
Like different departments built incident response assistants, HR co-pilots, IT troubleshooters, and they did all of this without requiring any additional integration work from the core development team.
Which is the dream, right?
Yeah. The developers didn't have to build 300 custom APIs. So how did they do it?
Well, what's fascinating here is that their secret wasn't necessarily writing brilliant code. It was their architectural approach to the data itself.
Okay, how so?
They explicitly separated the data layer from the compute layer. To do this, they used Azure Blob storage change feeds to trigger stateless Azure functions.
Okay, let me translate that for the listener for a second.
Yeah, go for it.
Instead of building a clunky system that constantly polls the database every 5 minutes, just asking, hey, did anything change? Did anything change?
Oh.
They made it event-driven.
Exactly.
A change feed simply sends an alert the second a document is updated or added. And a stateless Azure function is just a tiny piece of code that wakes up, processes that specific update, sends it to the AI search index, and then just goes back to sleep.
Right. It doesn't retain any memory of its own, which makes it incredibly cheap and lightning fast. It's a highly elegant solution.
So the data layer acts as the single source of truth.
Yes, and the ingestion pipeline just reacts naturally whenever something changes.
It's almost like they built a massive, centralized, highly purified water reservoir for an entire state.
Oh, I like that.
Instead of forcing 300 different towns to hike down to a muddy river with their own buckets to filter their own water, the core team purified the water once. They cleaned up the data once. And now, anyone in the company can just turn on a tap and get clean, secure data for their specific AI agent.
That's a perfect analogy. And the highest leverage decision they made in building that reservoir was the schema design.
Ah, the schema.
Right. They spent their time meticulously mapping document types, writing detailed descriptions optimized for Copilot's ranking system, and adding custom properties to track like how fresh a document was.
Proving that organizing the data correctly is the real key to AI success.
Exactly. If the underlying schema is clean, the agents flourish automatically.
And we are seeing that ecosystem flourish across the board in this newsletter. Claude Opus 5 is now officially available in M365 Copilot, which gives users the choice of different foundation models.
Which is a big deal for flexibility.
Huge. And over in SharePoint, administrators are getting a new Agent Access Insights heat map.
I saw that. That's super interesting.
Right. It visually shows admins exactly where AI agents are interacting with content, which obviously helps detect unusual access patterns if an agent starts summarizing sensitive financial docs it shouldn't even be looking at. And we're also getting AI-generated audio summaries of news in SharePoint.
Plus, we are seeing significant quality of life updates for the developers building these tools over in the Power Platform.
Yeah, what's new there?
Well, Power Apps developers get a new confirm function, it's confirm, for modern dialogues. It basically eliminates the need to build those clunky custom pop-ups from scratch.
Oh, thank goodness.
Right? And they're also getting new Azure Maps geospatial PCF components.
PCF, that stands for Power Apps Component Framework, right?
Correct.
It's basically the toolkit developers use to build custom visual elements when the standard out-of-the-box buttons aren't enough.
Exactly. And giving them native geospatial tools means these agents can interact with maps and location data much more seamlessly now.
Which brings up an interesting shift, because all of this requires serious heavy machinery.
Oh, yeah.
Building these massive data reservoirs and agentic workflows means that the tools used by DevOps and site reliability engineers, SREs, have to evolve just as fast.
Absolutely. As the complexity of what developers are building scales up, the operational tooling managing that infrastructure has to become faster and more deeply integrated into the AI's workflow.
Case in point.
Yeah.
The newsletter notes that Azure DevOps is finally getting a commit search feature.
Yes.
Developers can now find any specific code commit in seconds right in the browser. But, okay, I have to be a bit cynical here.
Uh-oh.
Why did it take Azure DevOps this long to add a search function that finds commits in seconds?
I mean, that's fair.
This feels like a feature we should have had a decade ago.
Yeah.
How many times have developers just resorted to using the grep command in the terminal to manually search through text files out of sheer frustration because the browser interface was just too slow?
Look, developers have certainly relied on command line workarounds like grep for years, and your cynicism is entirely justified for the traditional software era.
Thank you.
But you have to look at why Microsoft is prioritizing this specific search capability right now. We are moving heavily toward CLI, command line interface, agentic coding.
Right. The agents are in the terminal.
Exactly. Developers are increasingly staying inside their terminals, using AI agents to write, analyze, and test code right there.
Okay. So if you have an autonomous coding agent rapidly generating and committing code, that agent needs a way to instantly search the back-end repository to understand the history of the code base.
Yes. Having lightning-fast native search index perfectly on the back end is no longer a luxury for a human developer who might, wait 5 seconds for a page to load. It is an absolute necessity for an AI agent that will literally time out or hallucinate if it can't retrieve the commit history instantly.
Okay, that makes total sense now. The sheer volume of code commits generated by AI is going to explode.
It already is. The newsletter even highlights active community discussions around the 7 best Claude Code alternatives right now.
Showing how aggressively developers are looking for the best terminal-based AI assistants.
Exactly. And this connects right back to the Model Context Protocol we discussed earlier. Microsoft just announced version 2.0 of the official MCP C# SDK.
Making it easier for .NET developers to build those servers.
Right. We are essentially watching the foundation being laid for agents to talk to the infrastructure itself.
And that includes the financial infrastructure, which is wild. The Azure Resource Manager, or ARM MCP server, is getting new cost management and pricing tool sets.
And this is a crucial detail.
Yeah, because if you have an autonomous AI agent writing code, and that agent has the ability to spin up cloud servers to test that code, it needs a budget.
Desperately.
A rogue AI running up the corporate credit card by accidentally provisioning like 100 massive GPUs to test a simple script. That is the modern IT nightmare.
It really is. But by giving the agent native access to cost management via MCP, the AI can query the pricing, realize a massive GPU exceeds its allocated budget, and then choose a smaller, cheaper server autonomously.
It brings financial governance directly into the agent's reasoning loop.
Exactly. And for actually deploying that infrastructure, Terraform Azure M Provider 5.0 is now generally available, which solidifies that whole infrastructure as code foundation.
Plus, Microsoft is looking beyond just the public cloud. At the Azure Arc Server June forum, they announced updates for the Arc Server AI agent and multi-cloud connectors.
Right, meaning you can manage and deploy these AI capabilities across on-premises, servers, and edge environments, not just in Azure.
But, okay, we have to pause here and look at the consequence of all this capability, because we just gave autonomous agents native access to our cloud infrastructure, our code bases, our billing limits.
The attack surface has fundamentally changed.
Yes. We aren't just securing static data anymore. We're trying to secure systems against autonomous actors, which transitions us perfectly into these security and compliance updates.
And there is a massive industry alert in this section.
There is, and it genuinely stopped me in my tracks. An AI just cracked a post-quantum cipher in only 60 hours.
60 hours.
For context for you listening, a post-quantum cipher is an advanced cryptographic algorithm specifically designed to withstand attacks from future quantum computers.
They are incredibly complex.
And this specific cipher had just withstood 2 years of intensive human review by top cryptographers. They thought it was impenetrable, and the AI dismantled the math over a long weekend.
It did this by identifying patterns and anomalies in the mathematical structure that the human brain simply isn't wired to see, even after years of study.
So what does this all mean? I mean, if an AI can spot cryptographic flaws in 60 hours that human experts missed for years, are we entering a phase where we just have to fight fire with fire? Using AI to defend against AI, is software-based defense completely obsolete?
Well, it certainly proves the limits of software-based defense when the algorithms themselves become vulnerable to pattern-matching AI. And this perfectly illustrates why the security industry is scrambling to anchor trust in something physical.
Ah, physical hardware.
Yes, that is why the newsletter's update regarding YubiKey 5.8 is so critical right now.
A YubiKey being a physical USB-style security token you plug into your machine.
Exactly. The 5.8 update brings hardware-backed authorization to passkeys. The underlying logic here is that even if an AI compromises the cryptographic math protecting a network, it cannot physically reach out and touch the cryptographic chip on a YubiKey sitting on an employee's desk.
Right. Hardware becomes the ultimate fallback for zero-trust architecture when the algorithms fail. You need a physical anchor.
You absolutely do.
And the defenses really are mobilizing across the board to prep for this. Cloudflare announced they are now supporting post-quantum authentication to origins, upgrading the web's plumbing.
Microsoft is also pushing hard on endpoint verification. Intune is rolling out registry inventory,
which allows administrators to verify exactly what configurations and software are actually running on the physical devices connected to their networks.
Because you simply cannot secure what you cannot see. And as AI starts generating code dynamically on the fly, executing that untrusted code safely becomes a massive challenge.
The newsletter references a great update from John Saville on Windows Sandbox for this.
Yes.
Let's explain how this works really quick. Windows Sandbox is a built-in capability for isolating untrusted code. So if an AI generates a script, instead of running it on your main operating system where it could do damage,
it spins up a sandbox.
Right. Windows spins up a disposable, lightweight isolated instance of the OS. It runs the code in that sandbox to see what it does, and then literally throws the entire instance in the digital trash before it can touch the real network.
Which is part of a broader philosophical shift outlined by Charlie Bell from Microsoft in his piece on Project Perception.
What's the core idea there?
It's about rethinking security for the age of AI. We can't just build taller walls anymore. We have to change how we react when the attackers are autonomous and capable of learning our defenses in real time.
Which brings us to the human element of all this.
The most important part.
With the rules of software development, infrastructure, and cryptography being rewritten in front of our eyes, how are the human beings behind the screens supposed to adapt?
It's a daunting question.
We turn to the Learning and Certification section of the newsletter, where Microsoft just announced the Microsoft 365 Certified AI Services Administrator Associate. And they've also got the Microsoft Defender Challenge and Learn Live event coming up in August to level up security skills.
Yep.
But I got to ask, what exactly is an AI Services Administrator going to do all day? I mean, if the AI is running its own code, provisioning its own infrastructure, and cracking ciphers, is this job just clicking approve on the AI's budget requests?
Well, if we connect this to the bigger picture, it speaks to a massive shift in the tech workforce. The human role is evolving away from executing tasks to becoming the architects of the environment. The newsletter touches on a vital concept called harness and loop engineering.
Harness and loop engineering. Walk us through how that actually works in practice.
So it means designing the safety rails, the harness, and the planning cycles the loop that the agent operates within. Humans define the goals, set the financial boundaries, and most importantly, design the ontologies.
Right. There was a fascinating academic discussion mentioned in the trends section from Frank Coyle at UC Berkeley about why agentic systems desperately need ontologies to function.
Yes. An ontology is essentially the structured reality of your specific business. It is the rules of your world.
Give me an example.
So an AI model inherently knows what the word marketing means, right? But it doesn't inherently know that your specific marketing department shouldn't have access to unredacted HR salary data. It doesn't know how your company defines a qualified sales lead. The human administrator's job is to build and maintain those ontologies so the agents make autonomous decisions that actually align with the business's ethics and reality.
Wow, okay. It is like shifting from being a carpenter nailing boards together to build a house to being an urban city planner managing a grid.
Yes. You set the zoning laws, and the AI builds the structures.
And we are seeing this shift in broader industry trends as well. The newsletter mentions Microsoft open sourcing the MLVC, the machine learning video codec.
Right, which uses AI to vastly improve video compression.
And it does this fundamentally differently than traditional software, doesn't it?
Completely differently. Traditional compression looks for duplicate pixels across frames and groups them together to save space. AI video compression actually understands the content of the video.
That's crazy.
It is. It recognizes what a human face looks like, sends just a fraction of the data, and uses AI on the receiving device to dynamically reconstruct the face in high quality. It saves massive amounts of bandwidth.
So the intelligence is moving all the way down the stack to the fundamental protocols of the internet itself.
It's everywhere.
Man, let's take a breath and recap this journey, because Andrew Kagan's newsletter really painted an incredible, cohesive picture this week.
It really did.
We started in the engine room, looking at the 88% failure rate of AI pilots and how the model context protocol and vector memory in Azure Cosmos DB are fixing that.
Right.
We saw Microsoft deploy a massive internal reservoir of clean data to spawn hundreds of custom agents using Azure Blob Storage and functions.
The schema design being the real hero there.
Exactly. We looked at the heavy machinery required in DevOps, like lightning-fast commit search for autonomous coders and ARM-MCP for budget limits.
Yep.
And then we stared down the terrifying reality of AI cracking post-quantum cryptography, forcing us to anchor our security in physical hardware like YubiKeys, and rethink our jobs through harness and loop engineering.
Everything is interconnected right now. The tools are building the tools. And it leaves us with a lot to consider as we architect the next generation of enterprise systems.
It really does. And I want to leave you, our listener, with a final provocative thought to mull over, a thread to pull on after this deep dive is over.
Let's hear it.
We talked about an AI cracking a post-quantum cipher in 60 hours. And earlier, in the DevOps section, we touched on how MCP is laying the groundwork for agents to talk to infrastructure. Well, there is an emerging open-source standard called the Agent-to-Agent Protocol, or A2A, which allows AI agents to discover each other, negotiate, and collaborate entirely autonomously.
Oh, wow. When you put those two concepts together, autonomous collaboration and superhuman cryptographic pattern recognition, it raises a really profound question.
Right. How long until AI agents are the ones designing, evaluating, and deploying their own cryptographic protocols to talk to each other?
Will there come a point where human mathematicians no longer truly understand the math keeping our data safe?
Exactly. Will we simply have to trust that our defensive agents are smarter than the offensive agents trying to break in?
That is a terrifying but very real possibility.
It goes right back to the calculator metaphor from the very beginning. We aren't just punching in formulas anymore. We've hired the executive assistant, and now the assistant is rewriting the physical laws of the office. Thank you for joining us on this deep dive into Andrew Kagan's latest insights. Keep questioning the tools you use, keep learning the underlying mechanics, and we will catch you next time.